We're going to look at rational exponents. So a rational exponent is the same thing as a radical. For example, we've got the square root of, or x to the 1/2. That means the square root of x. And if that's being multiplied times 4, then we would just have the 4 outside of that square root symbol. So that's the same thing. Okay, so here the entire 4x is taken to the 1/2 power. 1/2 power means square root. Okay, so whatever the denominator is, that's the type of root that we have. Okay, so a square root, there's no 2 written, it's just implied that that's a 2. It's so common that we just don't even write it. We would just have it as a plain square root. So a to the 1/2 is the same thing as square root of a. Now, if here in this one we have -8 to the 2/3 power. Okay, the denominator tells us the kind of root. The numerator is telling us the kind of power. So here that would be the cube root of -8, and all of that is taken and squared. And if we wanted to actually simplify that, -8, the cube root of that means what times itself. 3 times is -8, and it's -2. And then when you square that, that's 4. Notice that the power of 2 and the root of 3 happen at the same time. So I could have written that as -8 squared, and then I could take the cube root of all of that. And you're going to end up getting the same answer. -8 squared is 64. What times itself 3 times is 64? It's 4. Okay, so either one of those will get you the correct answer. Those are the same thing. Okay, and so often it's easier to take the root first and then square it because our numbers are a little bit smaller. So that's a lot of times what we would do. And then on this next one, we have 1 divided by -8 to the 2/3. But here it is -1 is multiplying times 8 to the 2/3. That's different than if I had this -8, the whole entire -8 taken to the 2/3. Okay, so just be careful. If there's no parentheses, then the only thing we get to take to the 2/3 power is just the +8. So we'd take 8 to the root, to the cube root, and then square all of that. So we would get -1 times cube root of 8 is 2. 2 squared is 4. So this would be -1/4. And that's done. All right, let's try a couple more. Here we've got the entire, so it should be black, 8x to the 1/2. And now we have 8, and that's not affected by the 1/2 power. So there's no parentheses there. Okay, and now here we have the entire -64 taken to the 2/3 power, so we can take the cube root of -64 first and then square that. And here we would have, and we could get that final answer there. What times itself 4 times or 3 times is -64, and that is -4. And then when we squared -4, we would get a +16. Okay, so then here we have -64 to the 3/2. So the power is square root, or sorry, the power is 3. So this is the power, the numerator is the power, the denominator is telling us the kind of root. Okay, so we're taking -64 to this square root and then cubing that. Okay, great. So the square root of -64, that's actually not a real number. Not a real number. Because if we had -8 times -8, that gives us a +64. 8 times 8 gives us 64. We need a new number system, and we'll get into complex numbers later in the course. But that just is, for right now, we would just say not a real number. All right, so now let's put in some negative rational exponents. Okay, so this problem here, I have -64. Well, really, this is -1 times 64 to the -2/3 power. because the only thing being touched by that exponent is only the 64. It's the opposite of 64 to that power. Okay, so we would take -1 times. Now I have a negative exponent, so I'm going to take the reciprocal of 64 to the positive 2/3 power. Okay, numerator tells me the power, denominator tells me the root. So I'm going to take -1 times. It's the cube root of 1/64, and then I'm going to square that final answer. Okay, and so now I can take -1. When there's division inside of a radical sign, you can take the root of the numerator separately and the root of the denominator separately. Okay, and remember we still have to eventually square that. So we've got -1 times, cube root of 1 is just 1, cube root of 64, what times itself 3 times is 64, that's 4, and now I have to square that, so this ends up being -1 times, -1 times, 1/4 squared is 1 squared is 1, 4 squared is 16, so this ends up being a -1/16. There we go. Okay, let's try the next one. We can apply that squaring power to everything here. So I've got x to the -2/3. I'm going to square that, and then I've got y to the 4/5, and I'm going to square that. Okay, now we use the product rule, or the power rule of exponents. We get to just multiply. Okay, so we multiply that. We have a fraction times the number. Give our number a denominator of 1 and then multiply straight across in the numerator. So -2 times 2 is -4. 3 times 1 is 3 in the denominator. The same thing here with our y's. We would get, multiply straight across, we'd have 8 in the numerator. 5 times 1 is 5 in the denominator. Okay, and now I have a negative exponent here, so I'm going to write the reciprocal of x to the positive power. And 1 to any power is just 1, x to the 4/3, and then that's times y to the 8/5, and it would be conventional here just to go ahead and multiply those. We'll do our 1 times 8, or y to the 8/5, and then in the denominator I have x to the 4/3, and there's our final answer. That is done. So notice that we want our final answer to have positive exponents. All right, so that's what we're looking for there. So multiply. Okay, first thing I'm going to do is just use commutative property. I'm going to commute this x out here. So I've got x to the -3/8 times x to the -5/8, and then I have y to the 5th times y to the 2/3, and then I can use the product rule of exponents. I get to just add these. Okay, so I've got x to the -3/8 plus -5/8, and then that's times y to the 5 plus 2/3. And my x's already have the same denominator in those exponents, so I get to just combine that. That's x to the -8/8. So that would be x to the -1, which is 1 over x. All right, and then that's being multiplied by, let's see, we need a common denominator. So I give my 5 a denominator of 1, and then I want a common denominator, which I'm going to make 3. Whatever you do to the denominator, you have to do to the numerator as well. So it would be y to the 15/3 plus 2/3. And now I get to just combine numerators. So it would be 15 plus 2 is 7. And those stay thirds. We just combine numerators, keep that same denominator there of 3. Okay, and so now just multiplying that, you would go multiply straight across, so I would have y to the 17/3, and in the denominator I have x, or x to the 1. And that's done. Positive exponents are in my final answer. All right, so I'm going to give you a chance to try this next one. What I suggest doing first is simplifying inside this parentheses and then dealing with that negative exponent. So go ahead and get started. Combine your x's, combine your y's, and simplify in your parentheses. So go ahead and pause. All right, so we should have 3 times. It's x cubed minus those 2 from x's from the denominator, and then we have y squared minus that negative 1 from the denominator, and then we would have z. So inside the parentheses here, that simplifies to 3 times x. 3 minus 2 is 1, so it's x to the 1, or just x. And then minus a negative is plus the opposite of negative 1, so it would be y to the y cubed, and then z. And now we have to deal with our negative exponent. So we're going to write the reciprocal to the positive 2 power. So go ahead and finish this up. I'll give you a minute. You go ahead and pause, and then you can get your final answer. So we write the reciprocal and square that, and then go ahead and square everything. So there's our final answer.